Hello, very warm welcome to the IEEE Services 2020 global audience, to the plenary panel on Serviceology, Advancing Scientific Foundations for Modern Digital Services. We are in extraordinary times. All of us on this panel thank each and every one of you in making this conference possible and also in attending this plenary panel. We want you to be fully engaged. This is not a private conversation among panelists. So please use your Q&A tab on your portal to send us your comments as well as your questions. We're going to be fully addressing those. So let me say who's on the panel. So we have really serious thinkers, doers, and teachers in this panel. So I look forward very much to engaging the panelists. So I'm going to read out the names of the panelists right now, and then we'll have a proper introduction as each one of the panelists speak. So we have Shafqat Shu from Harbin Institute of Technology. Hi, Shafqat. We'll have Rong Chang from IBM Research, Carl Chang from Iowa State University, and Bhavani Thuraisingham from University of Texas, Dallas. And we have also our digital MC, who is going to be monitoring our Q&A and feeding your questions to the panelists. So let the questions keep coming. So so we're going to dive deep now into our topic. So I'm going to set this up and then invite Shafqat after I set it up to go through the motivations and challenges of Serviceology. So first, let's talk about, I notice my screen is distorted in the main panel. Can everyone see my screen?
Yes.
Yeah.
Okay. For some reason, that's better. Okay. So when we talk about Serviceology, I must admit that when I first heard that word, I was wondering, what are we talking about? So this is really the science and technology foundations or base for services R&D. That's really what we're talking about. When we talk about modern digital services, I want to paraphrase Immanuel Kant, who said that science without observations is empty. Observations without science is blind. So as we talk about science and technology here, we're going to be really grounded on examples of digital services. And that's how we're going to be, all of our panelists are going to motivate the topic. So we're going to spend the first half of the panel hearing from the panelists, and the second half really diving deep into the Q&A. So let's get some of the basics out of the way, because I know we have a very diverse and wide global audience. So first of all, just backing up a bit, when we talk about service systems is how we as humans transact, create, and exchange value. So it is part of our life experience. So if you're ordering delicious mooncakes in Beijing or Shanghai, or you're taking the metro in Mumbai or Tokyo, or you're shipping flowers, tulips and roses from Kenya to Paris, or containers from Rotterdam to Singapore, or if you're in the United States and unfortunately you have to walk into a clinic to get a COVID-19 test, or you're relaxing at home listening to the Berlin Philharmonic. All of those are service systems. They come in various forms. Service systems are the lifeblood of the world that we live in. It actually provides all of our experiences in a day-to-day. So it's not something strange. It's part of how we interact in the world. So then how do we position service computing? Service computing is the ICT, or the Information and Communication Technology Foundation, for manifesting these service systems. So designing, building, running, and managing these service systems. And IEEE, of course, IEEE Services is the largest technical community across all of these conferences looking at service computing. So that's what's so fascinating about the topic that we're going to be discussing about. So then Serviceology is really the pedagogy, practice, and the advancement of service computing, especially to bridge between business and IT. And that's so very important to bring both of those dimensions together. So you might be wondering, okay, so this looks like a very broad space. Indeed it is. So in fact, it's a fusion of many sciences. And we're going to get into this. And I want the panel to be a little bit provocative. So I took a stab at what are those sciences and technologies we're talking about? So just briefly. So first of all, as human beings, we are going to be interacting with the service systems. So the human beings interacting with first-class service objects in a dynamic context. So human-centered design becomes very important. And you're going to hear quite a bit of that as to how that plays into service computing. And of course, all of that digital experience is shaped by communications and control between service components. And that's what I mean by system cybernetics, right? So that plus the data-driven aspect of how these components interact makes up the back end. And for those of you who are more familiar with the serverless computing, so it's the functions interacting with the backstage. Of course, you need to also have the computer science foundations. I'm talking about classical things, distributed computing, information management, cybersecurity. And we're not forgetting all the modern things, Internet of Things, being able to create digital twins and all the cyber physical systems. That's the foundation. And bookending the stack is software engineering. Software makes services come alive. And so you need the full discipline of software engineering. And why are we doing all of this? To actually solve problems and make decisions. So we need management and social sciences. That's sort of in a nutshell, the fusion of sciences and technology that come together. So it's a very rich space, and we have got a very deeply experienced and a panel with a lot of expertise. So we should hear from them. And we're going to start off with, looking at Serviceology and its motivation and challenges. So I'm going to invite Shafqat to take us through his thoughts and share his experience about service computing. So let me first introduce Shafqat. For those of you who have been in IEEE services, know him very, very well. He is the president of Harbin Institute of Technology, the Weihai campus. He, along with me, is the co-chair, and I want to thank him for all his efforts in putting together the SCC set of activities. In the China Computer Federation, he's been a leader, a fellow, and a board member, and shaping really services computing in China. And he has many awards and accolades, and including the Outstanding Leadership Award from the Technical Committee of Service Computing. And his research interests, if you had seen his panel yesterday, he had gone through a lot of very interesting things that he has been doing in services, science, and engineering. So obviously that's his passion and expertise, enterprise interoperability, and of course, software engineering and data mining. And I'm sure I'm missing a lot of other things. So Shafqat, with that, to you, over to you.
Yeah, thank you. Thank you, Kumar, for your kind introduction about me. Yeah. And so, ladies and gentlemen, good morning, good evening. Yeah, it's my pleasure, to talk about Serviceology. Yeah, so I would like to show you my idea about the motivations and challenges on Serviceology. Just like described by Kumar. Yeah, so Serviceology is a very broad concept. I think it's very new ideas. Yeah, about how to describe the service. Here, I would like to show you the picture about my understanding about the service ecosystems. If you consider the service, so I think, so you mainly, so the people from service computing, we consider more about software services or IT-enabled services. And currently, these services so existed in the very new and complicated worlds. Internet plus A, B, C, D, E, F, G. I think you know the meaning of every characters. Yeah. So plus services in the society and economics. Yeah. And by the way, you have also human services. And so here, yeah, in this layer, yeah, we consider mainly about service functionality and service actions. In fact, all these services perform the business processes and then to implement the business services, then to create service value. So I think here mainly, if we consider service computing, mainly we concern more about IT-enabled services or software services in the complicated virtual world or virtual and the real comprehensive world. But if we concern more about the service itself, yeah. So I think yeah. So we need to have a new theoretical systems. Yeah. For service computing, yeah, we concern more about new and better solutions, technologies, and methods. And for the service science or serviceology, yeah, we concern more about the services and new and better value of services. Yeah. So and I do remember, yeah, in 2005, IBM, yeah, so initially presented so-called service science management and engineering. It was shortly named SSME. Yeah, but very quickly we find that yeah, so it's quite good. It's a multi-dimensional concept, but it's more or less complicated. Then so in 2007, yeah, in China we have a Ministry of Education and IBM mixed joint expert group on service science. So I was lucky. I was a member of this expert group. So we invent a term called Serviceology. Yeah. So to represent this concept. So Serviceology, yeah, so is a cross-disciplinary concept dealing with the laws, knowledge, technology, and management of services. And even in 2009, in China, our expert group, we have written and published a book, The Body of Knowledge on Serviceology for Universities. Yeah, it might be the first knowledge body book on serviceology or service science for the university education. Yeah. We think that so serviceology is a multidimensional and multidisciplinary comprehensive concept, but mainly include these parts. So including service science, service engineering, service management, service enabling technology, and interdisciplinary frontiers of services, or we call smart service applications. Yeah. So we can consider how can we move from service computing to serviceology. Yeah. In the scope of service computing, mainly we focus on IT-enabled services and networked service systems. Yeah. And while in the scope of serviceology, we mainly focus on the forms, laws, nature, value, business, ecosystems of complicated services. In such a way, it shows that so serviceology looks more multidisciplinary concept, including theory, methods, methodology of service sciences, service computing, service engineering, service management, service social technical ecosystems. So this and when we consider so what's the challenge? What's the challenge about service problems? I think so these problems could be identified as a critical problem Once the service law discovery, even we have a developed, have a research on service for more than 25 years. Yeah, but even though we need to consider how to define the forms, the nature of services, the objective law of formation and evaluation of complicated internet plus service ecosystems. And also we should consider service value. Yeah, because the purpose of service computing and service science is to create better service value. Yeah, so how to create and to evaluate the objective value of both customers and service providers in the value chain of a more complicated service environment is a problem. Yeah. And also, yeah, so we need to consider how to science and how to define the demands and experience of massive individualized customers, yeah, through human system interaction or directly, yeah, so through the Internet of Things facilities. Yeah, and we also, yeah, need to consider service business models, yeah, from the view not only IT aspects, but also from business aspects, yeah, to develop the new business models and to manage complicated socio-technical service, yeah, so across multi-domains and smart service worlds, yeah. And also, yeah, we need to consider the service adaptability, yeah. So, and then, so we think that, yeah, so this theory, yeah, should be very important, yeah, for serviceology to define and to solve the problems. Yeah. So one is the service law discovery. Yeah. The second is service business models and value theory. Yeah. From the multidimensional aspects. Yeah. And service methodology and optimization is our traditional research problem, but still we need to improve better. Yeah, and also we need to consider the cognitive requirement engineering to capture and to sense the mass individualized customer demands. Yeah, and also we need to consider the adaptive running of services and the service credibility and the security. Yeah, sure, we need to solve the problem. Yeah. These are my main idea. I just give my open remark about the motivations and the challenges. Thank you, Kumar.
Shafqat, thank you very much for giving us in a quick recap of a little bit of the history as well as all the dimensions of serviceology, and you can see it's pretty rich and broad. So now we get into the innards of what we in the panel want to really promote, this idea of services first, and we're going to hear from Rong next, and then followed by Ka. So let me introduce Rong. So Tom, if you can bring up my screen briefly. So it's a pleasure to introduce Rong. Rong and I are colleagues in IBM Research, and he's a dynamic leader. He is the chair of IEEE's Technical Committee on Services Computing. He is also driving the IEEE Services Symposia. You actually heard one of the panels yesterday on higher education on services. Within IBM, he is in the prestigious IBM Academy of Technology, and is also our professional community leader within Research Worldwide for Services. He's been an associate editor-in-chief for IEEE Transactions and Services Computing. Rong brings us deep expertise in creating these modern digital services, composable enterprise microservices. And all of those words, composable enterprise and microservices, are very, very important. And then, these services are cast in intelligent computing infrastructures, especially with, the broad adoption of AI and analytics. And then, of course, the underpinning of it is distributed computing. So his expertise is extremely relevant to the heart of services computing. Wrong, to you. Wrong, your mic is muted.
Sorry. It's good now? So so I'm honored to be on this panel while we are writing a new chapter on service-oriented distributed services computing. If we look at the evolution of the systems, we started out with the operating system that help human beings to manage applications running on a single machine. Then later on, we developed the so-called client-server computing model so that we can make the computing capabilities available from a remote location. Then we get into the kind of a server-driven evolution or the provider kind of a dominant evolution in which we keep expanding the capability on the server side, like a server cluster, HPC, high performance computing, etc. While the client side appear to be like a second class in the whole evolution. Now we are very encouraged to see gradually client is taking over the evolution in terms of API adoption and the specification. So essentially, I think we are really entering into a new world under the model of client service computing, in which we don't really care the servers at the high level. What we care about is what's the service, as Kumar just said, what's the value or capabilities that we like the both the consumer and the provider would like to exchange. So so that's why I said the second bullet is really talk about a key thing of this new chapter is really about API enabled service first distributed computing atop a hybrid cloud. The hybrid cloud is very important because it's not just about the computing traditional kind of CPU oriented computing power. It's also kind of address the need of having the data to be managed adequately. And many people call it kind of data gravity these days. And moreover, it's more than just the CPU or processing power, as well as the data that we need to manage. Also, the connection among all the kind of computing entities is really hard of the whole hybrid cloud. It's not driven by the computing power, but driven by the data distribution need, and as well the connection need of all the data and the computing power. So now I'm getting to the deeper on what I really feel the meaning of three important words. That is at the top we say composable enterprise microservices. Now microservices have been very popular these days also because the proliferation of container-based server deployment. Now, from my viewpoint, a bigger value of the microservice notion is really not from that IT perspective, but from the business perspective. Really saying that from a business perspective, we don't throw things away overnight and totally come with new computing systems. We actually evolve. Now, when we want to evolve, we want to add things into my current solutions incrementally. So that's why the notion of a microservice is so powerful. Is that really saying I want to add focused and manage the computing capabilities into existing solutions that satisfy all my non-functional requirements? That's really That's really the key thing, I think, key value of the notion of microservices. As Kumar said very well, the service is really about value and capability exchange. Now, from my perspective, I'm very focused on the technical part. That's really saying is really from the API perspective. That's one important perspective. It does not mean that API is the only important thing in the whole chapter we are writing, but that becomes very important thing because the API is the one that link application together. There's also other aspects that's very important. That's how to advance our human computer interface, that HCI. That is another important aspect I'm not covering in my perspective. So from there, you can see easily we can differentiate the microservices into two categories. One is called the IT microservice I mentioned earlier, like a container part-based cluster services in managing the Kubernetes environment. Another one is very important in the enterprise, in the commercial world, that is enterprise compliant kind of microservices. For example, the identity and access management services, many people take it for granted, but they don't really understand that's one of the most fundamental and important microservices every enterprise needs, or even on today's internet infrastructure. So now, why the composability is important? Because composability is enablement for cost-effective and efficient integration of intra-enterprise computing resources and the delivery, as well as inter-enterprise collaborations. Okay, so I put the formula below in the sub-bullet for that one is we have to think about microservice. It's not just microservice alone. Microservice is composed of other microservices. Then the composition is not arbitrary. It's not just in terms of a functional capability, but also taking into account many other non-functional properties, like the security assurance, like the assurance on the performance, assurance on the data privacy, assurance on the industrial regulations and compliance rules, etc. That's why I put another formula there is assurance of the microservices is very important. If some quote service cannot pass the assurance criteria evaluation, then it's not a composable microservice yet. Okay, that's a very important concept. When we say microservice, we want to talk about composable microservice because that's the only way we can program in the whole system large or manage the whole system large. If that's kind of one key essence that I want to share with everybody. So one important key design decisions. Now, when we design a system, we normally call it architecture design decisions. Really think about what are the microservices instances we have, and how they interconnect with each other. So it's not about the implementation details or the delivery details of each individual microservice, but at a higher level, say, how can we compose all the microservices we have developed together to satisfy a bigger need, to create a bigger society impact? That's the thing I think that's require a lot of work. While we have a lot of effort since the focus on the implementation of a specific microservices these days, I think we need to put more effort in really focusing on what happens if we already have all the fundamental microservices. How do we put them together? Because the complexity of putting all the technology together into a big solution is very, very high. It's growing exponentially. So lastly, I want to just mention three bullets about the scientific foundations that I can think about. The first one is I alluded earlier about the microservice design and continuous improvement. How can we do that in a tiny manner, and how to do that in a cost-effective way? The second one is really talk about cloud stack optimization. That is, once we move away all the service implement details in the client service model, now the question comes is, to what extent we can somehow orchestrate all the computing resources together in a holistic manner so that we can optimize the whole system all the way from the microservice API down to the hardware infrastructure, like a qubits, like a neurons and the bits. The last but not least is we have we have focused a lot about the numerical or matrix-based evaluation of our systems. I think we need to go back and revisit the heart of the design and the implementation of programming languages. We are essentially writing the cloud programs today like we did before, like in the 70s or 60s, writing in machine languages instructions or even system level code. We need to find a way to promote the level of cloud programming at a higher level programming language level with the service as a first class entity or concept in the programming language. So thank you for your attention.
Rong, thank you very much for taking us through, the machinery that you really need to bring services together. In fact, provide a melded experience, right? So it really sets us up very nicely for what we want to share with you next, because the service systems are really for the benefit of humanity. Don Norman, many years back, talked about the user-centered design, and we are going to think much beyond, much deeper than that, in the sense that, I briefly mentioned the three tuple, the human user, the microservices or the composed services that Rong talked about, and the context and the environment. And that's not even sufficient. You'll hear from Carl next on, the dynamicity around the context, how the human being is arranged in the context of the context, which is what is referred to as situations. And he's going to motivate in a very deep way what this really means from a service computing perspective. So first, let me say it's a great honor to have Carl in the panel. Carl's actually the driving force behind the IEEE Services 2020. He's the chair of the steering committee. In Iowa State, he heads the software engineering lab. And among many accolades, Carl has the Richard Mervyn Medal, which is the highest IEEE Computer Society honor, for voluntary services and exemplary leadership. And just as an aside, Richard Mervyn was an IBMer and a president of IEEE Computer Society as well. And Carl, among many other things, is a life fellow of IEEE, and he's a mentor for many people around the world in services computing. And his interests are in software engineering, human-computer interaction, and you're going to hear from him on situational analytics and digital health as to how you apply these services to health. So with that, Carl, over to you. Yeah.
Thank you, Kumar. Can you hear me? All right. So we have heard a lot of technologies and all this API, this service computing platform and the Serviceology, service science. I'm going to just give a little bit of twist here. I'm going to focus on just one aspect of service computing. And in my mind, I think that's a very important aspect. So I would like to come here to advocate that here the title says on my slides, Situation as a Service. I call it SITAS. I have been working in situation analytics for quite some time, probably since 2005. I would like to see if we can consider in Serviceology, situation analytics can be one of the science foundations. I think earlier you heard Kumar said that no, not just one science. Okay, you have many sciences in order to support Serviceology. Situation analytics, to me, this is a very important scientific frontier. The modern days software industry, we have to face a very diverse, very vibrant world. So in a sense that we have to deliver software services that have to cope with all these properties, including dynamic, cooperative, evaluable, autonomous, emergent, and situational. Situational is the property that I'm going to focus for this short talk. For that, I have to ask 3 questions here, not just to my peer panelists on the stage, but also all the audience everywhere in the world right now. How do we develop and how do we provide situational services? Of course, we need to have a definition of what that means. It's more than just in situ services. Very often we say, oh, that offers service in situ. It's more than that. Okay, situation is a very individual. I call this a humanistic term. It's not just technology. It's not just computing platform, or it's not just context aware. It's a situation. So even everything else is identical. Like your environment is the same, or your behavior is the same, but because you are different, distinct individual, you will perceive the situation differently. Second question is, what is the most difficult task if we would like to provide situational services? What is the most difficult? Among all the difficulties, what's the most difficult one? And third, I'm going to ask, in particular for my peer researchers, especially those researchers in software engineering, what is still lacking in the minds of software researchers? If you, my next slide, I'm give you my own answer to all these questions. So if you see the answer to the first two questions, you probably understand why I asked the third question. My answer to the question number 1, how to develop and provide situational services. As I said earlier, everyone is just a unique individual. So we need to be able to provide individual services in order to really create the value to each individual. Earlier, you heard Kumar mention about we transact and we create values, or human transact and create values. Okay, so human create values. It seems the focus is more on the developers, right? On the technologists, engineers, but create value for whom? Also for humans, okay, by and large. So I would like to bring your focus to the other end of the humans, not just developers or engineers. It's the customer on the human side. And the second question, what's the most difficult task for situational service provisioning? As I answered in the first question, I said that's a human dimension. Very often it's actually easier to deal with technology. I'm not saying quantum computing is easy, but human are just very different. Human is very versatile, very dynamic, very hard to manage. So after I answer the first two questions, my own answers, and then my third question is what is lacking in the minds of software researchers? Sorry, I use pretty strong words here. I just would like to bring to the attention of software engineering research in particular, almost totally occupied with the systems and environment, cloud computing, edge computing, IoT, but the much needed exploration, in my mind, into the human dimension for individual service is just pathetically inadequate. Nowadays, every time I saw an announcement of a lecture or seminar, people talking about human-centered computing, I get excited. So then I read the abstract. About 99% is about the so-called human-centered computing. Is about the human. Is about developers. It's about open source community. It's not really about the end user customers. And why I think this is the most difficult task? Because humans are very complex. Okay, so I just give you two pictures here. On the left, you see this is a very classic photo. This is in the good old days, President Johnson versus Senator Richard Russell. You can see that people have opinions about each other. So the signal is a human. How do we really tell the story out of this picture, right? So the human has very complex expression, very complex desire and intention. And software engineers or software service providers in the software industry, we have not really addressed that deep enough. On the right-hand side, you can see here, I just take a discover from Communications ACM journal. People behave differently. In a very simple, like on the main stage, only 5 of us here. But if you are in the crowd, you behave differently. Okay, in this particular digital edition of the IEEE Services Congress this year, you can say that you probably can get a feel out of it, right? So in the previous years, we last year we went to Milan. You can feel that's very different kind of atmosphere, and people behave differently. We try to walk from this building to that building, try to attend sessions. Now with the digital edition, you can see our audience now start behaving differently. I have been working and publishing in this area. So I think the first more concrete paper is 2009. I call it Situ. Situ is a framework. And later I have a much more readable version published in Computer 2016. And in my first formulation of the problem definition of the service of the so-called situation, I use D, A, and E. So D means desire, A means activity or actions, and E means the environment. Okay, later, I think I can extend this concept. Now I call it the MBE. E means environment. That means the most of the things we're talking about nowadays, like 5G, IoT, edge computing. We take a signal, we take information from the environment, and we create a system to provide service. And more people start talking about human-centered computing, especially people start working together with human scientists, like HCI researchers. They talk more about behavior. So we have a environmental context, behavior context, and what is the most largely, I think, neglected by the software engineering researchers is that we often forgot about this hidden context. It's a human mental context. So in order to really completely define a situation, you need all these 3 dimensions. Okay, you cannot just focus on environment or systems, or just say, I know, I studied the behavior, but without really studying deeper into the hidden mental context. So I just put this in a very short one slide to illustrate a little bit more on my rationale here. I define situation as a triplet. You have to be able to capture the mental context, behavior context, and the environmental context. And that defines situation to be a snapshot at that particular time point or time instance. Because as I said earlier, human beings are not static. We're very dynamic, evolving individual. So the way we perceive situation, the way we analyze the behavior and the environment, it's all different. So I think I mentioned that we need to look deeper into the human hidden context of a human mental state. So you probably know this. We do the sensing, we do observing, HCI or usability study, and then we need to focus more on perceiving from this point on. And the service environment, as I said earlier, you have to cater the service to your customers. So service environment is much more. I think if you're going to talk about individualized service, you have to dive into the hidden domain. So the service we said in the old good days, we just say we provide a service to a class of users, and now we talk about personalized service, but we only do that through parameterization. We try to enumerate all different possibilities, but you just cannot complete enumerate individual needs, come up with a complete set of parameters. It's impossible. So to offer individual service in order to serve the evolving and dynamic human, you have to start working more into the inner layer, as I put here in this onion ring. That's as a computer scientist, I just conclude with that. I think we have come a long way from the early days, the structure-oriented paradigm, functional decomposition, and now we are everybody working in object-oriented paradigm, object decomposition. I think we have already entered this paradigm. We may be not aware of it. We start thinking about individual service. For example, we like to analyze the customer's keystroke. We try to understand what the person is trying to buy from Amazon. But we have not gone deep enough, and also advances in the area of brain sciences or psychophysiology. All these things we have not really, the software engineers, software researchers have not really worked together with such kind of sciences. And I think we need a new abstraction besides the functional abstraction, besides the object-oriented abstraction. We should have a more powerful, more flexible, dynamic abstraction. I call it situation. The way I define it is the three tuples, the triplet you heard about. If we can have that abstraction, we can have a better, more powerful way to offer individualized services. I hope I have brought your attention to these needs, individualization. So I think I will just stop there, and some references if I'm interested in read it. That's all. So I'm going to stop sharing here. And sorry, I'll be a little bit longer.
Carl, thank you very much. I mean, I think you brought forward really intriguing and deep thoughts here, and we'll come back to this, I'm sure, in our discussion, because the human dimension is at the center of service computing. So, in light of the time, I'm going to very quickly go through a few thoughts that I also want to share with the panelists and with the audience, just to motivate discussions more than anything else. And then we'll get into, hearing from Professor Bhavani just after this. So let me remind our audience that, this is not just a conversation among the panelists. We want your thoughts. So please keep the questions coming and also your comments. You may have also certain deep ideas or things you disagree with what we are saying here in the panel. So, okay, so let me share a few things, mostly as motifs to characterize the digital services more than anything else. Do strongly believe that a lot of what we are seeing in the world today is going to be digital. It is getting digital heavily across industries. Data or empiricism is at the heart of a lot of what is going on, and we cannot ignore that. And that actually informs us as to how the services are going to be fashioned. And as Rong had described, and also Shafqat touched on, a lot of these services have to bridge between business and IT, and that would require, these API. And I call it API economies because this has to be viewed in the context of, the business needs. And then, it's the reality that many things that we are going to be consuming are going to be delivered on cloud. And when you hear from Bhavani, you'll see that, cybersecurity is going to be at the heart of it. So security and trust, without that, it's very difficult to imagine any service system really functioning. Right. So we heard on our opening keynote from Beijing when Fei Li talked about data. Data is growing exponentially. We all know that, right? And it's incredible amounts. I mean, I just to put this in context, right? We're talking about zettabytes. This is 10 power 21. So huge amounts of data. They're not all in one place. These are data sources all over the place. And, in fact, in our experience working with clients across various industries, what we do notice is what we call dark data. That is 80% of the data is still not fully mined because they are all in different modalities, many in a textual form, not easily amenable for analysis. So there's a lot of work in data. I just want to stress that. This is obvious to people as to what is happening with enterprises. Most of the enterprises are looking at a variety of competing factors, but they're all the economics are driving them towards digital, right? Just to give you an example, you do a banking transaction digitally versus walking into a branch, you're talking about 10 cents versus $4 per transaction. So the economies are massively different, which is what is motivating the industries to go heavily towards digital, right? And it also brings more of the data acquisition and being able to have more informed decisions, right? And agility and the dynamicity that Carl talked about, hugely important in the enterprise setting. And this is just a motif as to what is really going on with service systems. I am seeing the screen as a little bit warped, but hopefully you're seeing it clearly. All these service systems, inspire these digital journeys, right? So here's a simple example of an insurance claim process. There is some alerts going to the human user. There's the actual weather damage that happens. You're using drones and Internet of Things to actually get an assessment of that damage. There is a variety of autonomous decision systems that come into play in the context of a process, and the degree of autonomy would vary. You always have human in the loop to make sure that whatever decisions are being made is truly explainable, right? And so you can never avoid the human being in the loop. And this is the kind of process choreography that brings into play a number of different technologies, from AI and analytics to distributed ledgers, because you have multiple parties across transcending geographical boundaries, multiple trust domains. How do you ensure that you have privacy and trust across this space? And then, of course, all of these technologies have to be brought together in a seamless way. And that's where services computing shine, right? Being able to do this bridging between the business needs and a variety of IT capabilities. So then that brings to much the way Carl talked about a situational centric paradigm. From my point of view, I look at how human intelligence and artificial intelligence have to all come together. And as Rong and I always talk about, service is a universal wrapper for everything, right? So you have data, and then you have information that comes after analysis. Then you have knowledge as part of the analysis and reasoning, and service encapsulates that. I don't mean in a simplistic sense just one, but multiple services together. On the left-hand side, I just threw this up as, Benjamin Bloom was an educational psychologist, and he talked about this cognitive framework, at different levels. There are 6 levels of it. I don't have to go through every one of these levels, but just want to say the following. When you hear about artificial intelligence, we always talk about narrow AI and broad AI. Narrow AI is task-oriented. So only the first 3 levels, that is remembering facts and knowledge, understanding them, and applying them. That's where most of the AI that is deployed at scale is, right? Going beyond that to very tacit reasoning and processes is still work in progress. There's a lot of R&D. In fact, the outcome from our panel is to inspire R&D. So there's a lot of R&D still remains to be done. How do we bring these things together in services computing? And then you will hear this notion of business platforms. This goes back to what Shafqat was talking about. When you step from service computing to Serviceology, you actually bridge to build that business platform that brings people, process, and information together in the context of solving a particular problem, right? And then that includes not just technology. It includes compliance and regulatory aspects, which is what service law that Shafqat mentioned. All of those things have to come together, right? So that's what we mean by business platform. And you hear that word quite a lot in industry, but it's strong underpinnings in terms of scientific foundations. And so another motif that I want to leave with, so we progressively build from a process to a platform to an ecosystem. So when now we're talking about a services ecosystem, we're talking about modern services networks, right? So in fact, there was in one of the panels a discussion about ecosystems. So these ecosystems are service networks. So what do we mean by ecosystems? So when we talk about digital ecosystems, right, they are clearly multi-actor. And the way in which value is created and allocated is non-linear, and they are multi-directional relationships between partners in the ecosystem. So it's a combination of technology innovation, behavioral expectation, and regulatory aspects. That's what brings these things together. And the two examples that you see here is one is Amazon, which brings together as a host many different capabilities. So it's a single orchestrated ecosystem. But then you have also like in logistics, when container shipments, Maersk, which is one of the largest shipping liners, along with IBM, has created this blockchain-based trade lanes as an example, right? And there's a lot to be studied here when we talk about ecosystems, all the way from digital privacy and trust to, how do you enable collaboration across enterprises in the context of various business problems, right? And then I want to leave you with this idea that, computing is also changing. The business needs are changing. Compute is also changing. So the classical computing environment, which is the bits, and you see the picture of Claude Shannon there, is actually coming together with very special purpose AI hardware. Because when we talk about AI, it's very power hungry, and you need to have very specialized compute capabilities to do AI, and again protect the AI models from adversarial attacks and things like that. So you need capabilities there in terms of AI systems. And then, of course, as Carl mentioned, quantum. So all of these things are brought together in the context of a platform. And here's where services shine. Because, under the covers, you may have all these fancy compute engines, but you can actually have that decoupling with the service abstractions on top of it. But we need to be mindful of what compute allows us to do, the new kinds of business models. And that's where innovation comes in. And I'm going to stop there and going to invite next Professor Bhavani Thuraisingham. So Tom, if you can show my screen, I want to introduce Bhavani. Yeah. So Professor Thuraisingham is an executive director in the University of Texas, Dallas. She is straddled between industry and academia, having worked in many years in the industry and in the government, as well as in academia. And she also straddles geographies, both in the U.S. as well as as a visiting senior research fellow at the King's College in University of London. She's an IEEE fellow, ACM fellow, and AAAS fellow, and I'm sure I'm missing a few others. And there's a number of accolades she has, and it's truly one of the ones that I wanted to point out was she's the recipient of the IEEE Services Computing Research Innovation Award and in 2017. And her research interests are in cybersecurity, where she teaches the teachers, so to speak, on cybersecurity and AI and data science, as well as information assurance. So with that, Bhavani, over to you.
Thank you very much, Dr. Kumar. Can you hear me?
Yes.
Yes. So my talk is going to be on integrating machine learning and cybersecurity services for various applications, including Internet of Transportation, as well as cloud. So I'm going to talk about privacy-aware, policy-based data management. Very briefly, I'm going to discuss these subjects and then stress on what we can do with services. Machine learning services for cybersecurity, and then cybersecurity services for machine learning, and then how do you apply all of them in the Internet of Transportation systems, and the role of the cloud. Okay. So the privacy-aware, policy-based data management systems, what we are doing is that we are sort of integrating all of the data about a person. So the health-related information, the fitness data, location data, social media data, image, videos, and so on. It's all going into our smartphone. And so the smartphone carries out various operations, including data collection, data storage, data analytics, data sharing. And in fact, Dr. Kumar had talked about data, right? Massive amounts of data being collected about the various individuals. But then that will cause privacy concerns, right? Because all this data is being collected and stored and shared and so on. Of course, some of the data will be stored in the cloud and encrypted, and some of the other data will be provided as cloud-based services. And so what we are designing and developing is what's called this privacy-aware quantified self-manager, which is also policy-based. So what we are saying is every step of the way, collecting data, storing data, analysis, as well as sharing, is governed by policies. So the question is, what is the role of services, right? So data collection offered as a collection of services. Data storage, again, offered as a collection of services. Similarly, data analytics services, data sharing services, how do you put it all together? And so what sort of web services are we are also looking at microservices and XACML-based policy for these services. So that's the area that we are looking at in addition to working on these policy-based services. So that's what I'm saying here. What we are developing is this smartphone data management framework, and then using the cloud-based services to store some of the data, and that data is being stored as encrypted data. So essentially what we are saying here is that lots of data being collected, so privacy is being violated, and then we are envisioning that data sharing and analytics will be carried through various services. And again, we may not want to store all of the data, right? So for a 20-year-old, we may not want to store the daily weight, but for a 70-year-old, we may want to store the daily weight. And so again, there are three things that are coming together here: privacy, policy, data management. In addition, we also have to bring in services, because if not, you can't have really a monolithic system providing all these features, right? We have to be able to decompose and perhaps use these microservices and develop this complete system. So that's the direction we are taking in this area. The second is machine learning services for cybersecurity. So what we are doing here, again, when you look at the general idea here, is that data is coming continuously in terms of data streams. And what's happening is that the concepts are going to change when data is emanating in the form of streams, because it's continuously, the concepts are going to be changing. So what we do here is develop a collection of models, right? The classification models. There is no such thing as one model. So the models are continuously changing. So when we have the test case, the models are applied. If it's attack, of course, it goes and quarantines. Otherwise, benign traffic is going to the server. But the models are continuously being updated because the patterns and the trends and the concepts are changing. And there could be a human in the loop. And again, where does this come in? So we can offer this as a collection of services for machine learning services for cybersecurity. But again, what types of services, right? We can encapsulate this whole thing into one service, but then that's not going to work. So the challenge here is, how do we decompose into these different services? So when we talk about classification, there are different aspects of classification. Suppose, say, we are using support vector machine. So that's the direction that we are taking. And so services, I believe, are going to play an important role. And so this is our architecture where, the I chunks are coming in and they are being used for testing. We are using supervised learning, unsupervised learning, and then the I+1 chunk comes in, of course, for training, and then you test. And again, all of this, what's going on here, online learning, we can offer them as one big service, but ideally we want to take it apart and offer them as a collection of services. And that's the challenge that we are facing. So if you want performance, then we cannot offer just one system. We have to break them into services. Another very interesting aspect is cybersecurity services for machine learning. This is where I think the cybersecurity community is coming into some problems applying these services. A lot of opportunities for research here. So what do we mean? The general idea is adversarial machine learning. So what happens here is that the adversary is trying to learn our machine learning models, trying to look at our data, and then trying to poison our data, putting bad data, and then learning our models and adapt its behavior. So this is really the support vector machine line, a machine learning system. So what's happening? The adversary is learning what we are doing, and then some of the red squares are the bad instances, the blue circles are good instances. It's pushing the bad instances to pretend to be good instances, so it's not getting caught. Okay, so I'll tell you what we are doing in this area is that we have the support vector machine line is here, but we are now trying to be one step or several steps ahead of the adversary, looking at the different types of attack and trying to see whether we can try to move the support vector machine line somewhere here without sort of sacrificing accuracy. So if we can do that in an intelligent way, then some of the red, so here the red crosses are bad, the green circles are the good instances. And so some of the bad instances could be caught. Of course, we can move this line somewhere here. And then that way we can catch all the bad instances, but then we are going to have false positives. So we don't want false positives or false negatives. So that's what we are doing here. By moving the line, we have a lot of the bad instances are being caught. So black dash line is a standard supported vector machine. Blue line is the adversarial support vector machine. Okay, so now we have this complete adversarial machine learning algorithm. So the challenge here, whereas in the earlier cases, I think we have a fairly good handle how to bring in the web services and in particular the microservices into decompose the machine learning services, the privacy aware services, and offer them as a collection of services, because sometimes we may not need some of the services. Whereas in this particular problem, that's where there's a challenge. How we have an adversarial machine learning technique, but how do we break it apart into services? So that could be a huge research direction for our services computing community. Okay, so now how do we apply all of this into this whole Internet of Transportation, right? Internet of Things, again, it's a collection of services. Similarly, Internet of Transportation, the autonomous vehicles talking to each other and the trains talking to the vehicles and the trucks talking to each other. So we have a paper at the Usenet Security on security and privacy for the Internet of Transportation. But again, how do you offer all of these interactions as a collection of services? That is the challenge. And how do you bring in AI into this whole picture? Okay, so that's another area direction that's showing a lot of promise. So what we are doing again with respect to privacy for Internet of Transportation, the same thing, the data collection, data storage, data analytics, data sharing. And then instead of healthcare data, social media data, and so on, we have radar, GPS, cameras, LIDAR, ultrasonic sensors, and then some of the data being encrypted in the cloud, and then some other data anonymized, and then we can query and provide cloud-based services are providing us with some of the results. And then we are building this privacy-aware autonomous vehicle, right? So this is, when I say we are building, we are planning to build, whereas the earlier picture I showed is something that we have fairly developed, but what we are doing there is looking at this microservices-based architecture. So this is sort of the future, privacy for these autonomous vehicles, because we don't want everyone to know everything about us, right? When all of this data being collected. So again, how do you bring microservices into this picture? And similarly, finally, the role of the cloud, because cloud-based services are going to be the future, right? A lot of the stuff that I mentioned, whether we are talking about security, whether we are talking about machine learning, data science, AI, it's going to be offered in the cloud because we need the cloud for scalability. And so one of the things that we have developed here with the cloud is this information sharing services and bringing in security. So we have policy-based services for secure information sharing. Then we have got the semantic web-based services for data exchange and querying. And so what I'm showing here is either it could be agencies like organized. So we have demonstrated this actually between UT Dallas, King's College, University of London, and University of Insubria in Italy, where we have exchanged all of the data using a service-based architecture in the cloud, where we put all of the data and the policies in the cloud, and then we share information according to the policies. So the challenge is, how can we bring this cloud-based, service-based architecture into the autonomous vehicles? So we have, instead of agencies, we have autonomous vehicle 1, vehicle 2, vehicle 3, and how can they share? So I'd like to acknowledge all of my colleagues. So the challenge, again, the previous speakers, they gave an excellent talk about the fundamentals of services, right? Serviceology, it sort of deals with the foundations that all of the speakers talked about. But what I'm discussing is, how do we apply that, right? So our focus has been more applying these web services, in particular microservices, into this entire environment. But the challenge is to integrate this sort of work with some of the foundations discussed by the previous speakers in the area of serviceology. So we haven't really thought a lot about serviceology, but from what the previous speakers have said, all of them, all four of them, it's really some outstanding fundamental ideas that we can bring to this environment, which is integrating AI, cybersecurity, and services. So we are getting some promising results. The only area, as I said, we are struggling with a bit to bring services in this whole adversarial machine learning space. And I think that's partly because, very quickly I want to say, partly because we are just sort of the cybersecurity community is just beginning sort of research, in the sense the last 5-6 years. So it's still very much in the infancy to develop viable adversarial machine learning techniques. And maybe once we have a handle on that, we can also bring in the services to enhance the whole system, and also to improve scalability. So this is my presentation, and I'll stop sharing.
So, Professor Bhavani, thank you very much. It's very informative, and as you pointed out, there are multiple research dimensions that go to the topic at hand. So now we switch to, we still have a little bit time to go through the Q&A. So there are, a few questions, and, I might actually mix in my questions as well as part of that. So the first question is for Shafqat. The question really is bridging between services computing and serviceology, and, whether there are any concrete examples to share to demonstrate progress is the question. And I want to add to that, Shafqat, that since you've been involved in the services science from the inception, right? But there's always been this nagging identity issue of what is the science behind services computing. So as you answer this question, please also share your perspective on how we can probably put this behind us, right?
Yeah. Thank you, Kumar. Yeah. So this is a very challengeable questions, even it's fundamental questions. Yeah. So I think, so the purpose of this panel is to consider, so what's the scientific foundation for services? Yeah. I think some problems we should consider. First is a concept of service itself. Yeah. So when we talk about services, different people, so they in their brains, so they talk about different issues. So I think we need to make clear the service concept transformation and unification between two domains, especially IT domains and business domains. Yeah, so we need to make it a bridge, transforming bridge over the gaps between functional service entities and business service. Especially we focus on service value. Yeah, because the purpose of the service is to create value. Yeah, so I think, yeah, so the concept definition or description is first critical problem. Second one is how can we describe? Yeah, so how can we describe service property and law? Yeah, I think here the model again. Yeah, we take the model again. Yeah, so the for the complicated services, how can we develop the model? Yeah, so from the multi-view, yeah, multi-disciplinary view and multi-dimensional view, yeah, for on the social technical complicated service ecosystem, yeah. So it's so far it's not very clear, I think, yeah. So the third one is yeah, so we consider service value. If we talk about the value, yeah, so different people have different view, yeah, different viewpoint. I think we need to consider the metrics, yeah, to measure the value, yeah, by means of multi aspects. Yeah, so this multidisciplinary, multi-dimensional evaluation standards from the view of not only economic but also the customer satisfaction. Yeah, so the experience and the psychological experience, I think, yeah. So and then so we need to consider, yeah, so the service demands, especially, yeah, so we concern more about how to sense and cognize and identify, yeah, the mass individualized customers demands, yeah. So and then so finally but not last, yeah, so the service new service engineering, yeah, and new methodology and paradigm, yeah. So before we consider more serviceology and service engineering from the zero foundation, yeah, so to set up the services. Currently, we have a very rich service network, yes, internet plus services. So we need to consider to how to match the service demand and the service provide delivery solutions. Yeah. We need such kind of the new methodology based on the rich service resources. Yeah. We need to consider the service convergence from multi-domains, multi-network, and multi-worlds. I presented a new concept, a big service. Yeah. So 2 years ago in San Francisco, I delivered a keynote about from big data to big service in IEEE service 2018. Yeah, so I presented my idea about the new service development paradigm. Yeah, so and finally, I think the new IT enabling technology for services necessary. I think these are my consideration about.
Yeah, thank you, Shafi. I think you put it well. I mean, there's a transformative dimension and a transdisciplinary aspect with so many stakeholders. So it's a fairly complex space to straddle. So, Carl, we actually have an interesting comment. And I'd probably add a question to that as well and get your thoughts on this. So the comments really is about, the whole business space seems to be, mass commoditization, trying to make the most money with the lowest cost, so to speak, across the board. So in that context, how do you sort of reconcile the individualized service is the comment. It looks like a little bit of a philosophical point there, but I want to bring up also related to that, another question, right? And you brought the aspect of software and services. It's almost like two cousins, right? Software and services. I mean, as the saying goes, we may not have it all together, but together we have it all. So how do we actually reconcile these spaces? Maybe the situation-centric paradigm enables us to do that. You're on mute, Carl.
Thank you, Kumar, for these two questions. Actually, your question is easier to answer because now it's software-defined everything. So service and the software, we have a software-defined services. In my research, I call it software-defined situations to provide individual services. So just tie all this together. The other question is more philosophical. Yes, I think I can answer the other question from two aspects. Why and why not? Why we need to offer individualized service? Just I look at it, the screen I'm looking at right now. This is the underlying platform for virtual conferencing. The contrast is making my eyes very hurting, very difficult. Why my computer cannot realize that? Why my computer cannot sense I have a need to have this the background, the contrast to be sharper, so that I can really see it easily. Technology is there for this particular problem because you can automatically adjust the contrast over the computer, I think, right? But I think the mindset is not there. The software designer, this is actually very clean, very elegant design, but doesn't fit my eyes. That's what I mean, the individual service individual needs. Why not? Because the technology is not really there yet. All right. At the turn of the 20th century, when the telephone industry starts, and people start projecting that maybe all the women in the U.S. had to become a telephone operator in order to meet the demands. But then after transistor, after the IC, all this electronic digital switch came out, it never happened. So once you have a disruptive technology arrive at the scene, then you probably will be able to offer individual service, and the cost economy for offering individual service probably will be there.
Well said. Thank you very much. And I think we are sort of when you're having fun, you don't watch the time. We're just almost run out of time. But I want to actually, on behalf of the panel, right, sort of bring up one summary view before we call it an end. So Tom, if you can bring up my screen. And, this is just to share some ideas as we went through the panel, right? A lot of very interesting and rich ideas. What are some of the things we want to, leave the audience with? Clearly, we want to advance services R&D. This is very important for us, for the community as a whole. And that brings together academia and industry, right? And you can see that in this panel. When we come from different perspectives, it's a very rich experience. The other aspect of it is from a service computing point of view. A lot of it is going to be, and Bhavani mentioned this, is cloud native, and Rong mentioned this as well. And I put there everything as a service, right? So it's cloud native, intelligent everything as a service. And the intelligence goes all the way from the human end to various autonomous systems. So it brings together also this idea of data. Where's the data going to be? Is it in the edge as autonomous vehicles, or is it going to be in the cloud, or is it going to be somewhere in between? And that data is going to shift from edge to edgy cloud to cloudy edge to clouds. So you got a full spectrum of things. So that's another one. And then Carl talked about the collaborative intelligence, the human and technology, rather, AI symbiosis, right? And that we need to really look deeper. And as human beings, the service systems and service computing is for the humanity. So that's very important. And then finally, with all the data and the services being so pervasive, AI and security, and Bhavani touched on this, and the significance of this. And I called it the zero trust cybersecurity because, when the services are so open, the traditional perimeter-based models won't work for security. It needs to be very contextual, very granular. And that's sort of in a nutshell, sort of the big themes from our panel and takeaways. So I actually want to thank the panelists for their expertise and their willingness to share these ideas. Thank you very much.